We're going to work an exponential model given 2 points. This task is a general task which can be used for a lot of exponential application problems. And we're not going to do much with it other than build the model. This is a method that will work for any situation where you have to build an exponential model and you can arrive at 2 points that go through an equation of the form y equals a times b to the x. Now, sometimes a story will not give you those points and you have to infer those points or create them from the story. Sometimes a story does give them to you. There's just different ways that it might happen. When one of those points that are given to you has the input variable 0, the problem is much easier. We will work one here that does not have a 0 as the input variable so that you can see a more difficult example. Now what we're going to do is just plug in these coordinate pairs into the equation prototype here. So we have the y is 29.9 and the x is 3. And then we have the y is 15 and the x is 14. There's a few different ways of doing the work from here. I recommend just divide both equations. And the way that would look is, it doesn't matter which one goes on top and which one goes on bottom, but I like the one with the bigger power to be on top. So the bigger power is 14. So I would write 15 and then a times b to the 14 and then fraction line for the division. And then in the bottom is a 29.9 a times b cubed. And what this does is it eliminates one of the variables so that you can proceed with basic algebra. And in fact, it does more because the b's will simplify. And in this case, you'll get b to the 11. You subtract those powers. From here, you just take the 11th root of both sides. And so the b is the 11th root of 15 divided by 29.9, which is approximately 0.9392. And so this tells us that y is equal to a times 0.9392 to the x. And to get a, we just pick either coordinate point, a coordinate pair, and set it up again. So maybe we take the 29.9 is equal to a times 0.9392 to the 3. And this tells us that a is 29.9 divided by 0.9392 cubed, which is approximately 36,090. You can carry different decimals on this rounding. The issue with these types of problems is oftentimes there's a lot of rounding error. I'm sorry, 36.090. I forgot to write the decimal. There's a lot of rounding error. Depending on how many digits you keep as you go. Now, one really interesting thing about this is oftentimes a student will write down something like 0.9392 for the b, but when they enter it into the calculator, their calculator still remembers the 9392 with all of the extra digits, and so the student will pull from the memory all of those extra digits and make a new calculation that's actually more accurate than what they've written. So oftentimes you could run into these rounding error issues. They will manifest mostly when you are comparing your answer to the answer of the teacher or the book, or if you don't round in the exact same way as a computer software does kind of in that journey, and you're expected to enter your answer into a computer, this could be an issue as well. In general, if you have very large numbers, like in the thousands or tens of thousands, millions, and so on, the larger the number you have, the more decimal you should carry, so that when you multiply the results are more accurate. As you multiply by larger and larger numbers, you move the decimal over more and more. And so if you round in an ineffective way, you lose information. So our answer will be, let's say, 36.090 times 0.9392 to the x. So there's our model. From here, once we have the model, of course, we can evaluate and solve. So we can plug in new values of x and get new values of y, or we can take y values that we know or want to know about and solve to find the x.